Okay, welcome everybody to the first meeting of 2025 for the Technical Advisory Council of the Confidential Computing Consortium. If this is your first time here, we are an open and collaborative community. Every project within our charter is welcome. Every person is welcome to attend and contribute constructively. In a few slides, we will create some space for you to come introduce yourself if you haven't introduced yourself to the group before. One of the other things that we have is an antitrust policy that we abide by. So we have a lot of different companies here. And you can read more about that on the Linux Foundation website. For today, we're starting the year off with some good meaty topics. Mark Novak has Mark on here. Mark Novak has introduced a topic for workload identity, and we want to get that discussion while he's able to join us in the first hour, and then we will move into our first project proposal of the year from a project that Caroline introduced to us in a tech talk in the fall. And then we have for dessert here a tech talk on decentralized storage from Wukaj. So good complete meeting here. And then we'll have a few announcements up front as well. Were there any other topics that I missed in getting the agenda assembled for this week? Okay. First little order of business is just double check representatives from the premier companies. Everybody's welcome to contribute in this community, but in the rare cases like voting in a project, those go to the votes of the premier companies. So I see Nathaniel on. I see Paul on. I do not see Catherine. This is always a difficult time for Howard. So I don't think I see Howard. I'm here, Henry or Kevin. So we might want to, we might want to check in with Meta next week.
I can do that.
Okay. Thanks for joining, Alec. And I think I saw Fritz as well. Yep. And Yash. Yep. And Mingshen or Yao. See either of them. Okay, but Mingshen, I think, was in the board meeting yesterday, so I think we still have the right representatives there for TikTok. Okay, and now this is the part of the meeting where if you would like to introduce yourself to the rest of the community here, feel free to jump off of mute. Let us know how you like to be addressed, where you're joining from, and we're always interested to hear what draws you to confidential computing.
Hello, everyone. Can you hear me?
Yeah.
We can.
Nice. My name is Spiros Seimenis. I'm joining from Greece. I work for the platform security team with Canonical Ubuntu. I think this is the first time I'm joining in person, but I've been following with the recordings for quite some time. And yeah, I'm glad to be here.
Well, that's great. That's it's fun to hear that you make use of the recordings. I'm glad we do those.
Yep.
All right, welcome.
Yeah, hi, I'm Lucas or Magic. I will be giving the talk later on about confidential compute and how it can apply to decentralized networks in general. And I work for Korea Storage, which is a company working on the decentralized storage network, Filecoin.
Well, thanks for volunteering to give us a tech talk today. I'm looking forward to that.
Daniel here from New York. I also helped start the Decentralized Storage Alliance, and Magic, as part of Curio, is part of that alliance. And we have a few other companies that are also part of this consortium. So yeah, excited to be here. Also co-founder of Akave that builds a decentralized storage network. on top of Filecoin to make Filecoin easier to use and provide hot storage for users of decentralized storage.
Very cool. Thanks for joining.
Yes, Johan, yeah, I'm joining from South Africa. I work for Seal Storage, one of the Filecoin service providers based in the USA, and also part of the DSA involved there. And yeah, using Magic's Curio quite extensively.
All right, nice to have a second South African on. the
Indeed,
call.
yeah. Lucky you, Rian. Rian, you should wave to Johan wherever he's based.
Yeah, I saw Kleinans and I thought, that must be. So-
Caught me out.
All right, well, if anybody else would like to introduce themselves as we go on, we're very open, so feel free to do that as we go. If you remember back to the end of 2024, what we finalized was the goals. So we want to have enough continuity in what we're doing throughout the year that we materially advance some aspect of confidential computing. So each of the TAC members has some goal area that they're helping us keep pace on. And we looked at one or two, I think, of the documents from the GRC SIG, and we had a couple of tech talks, including one from the UCLA Trustworthy AI Lab, and they've since joined as associate members. All right, and now we get into the announcements. Rian or Yash, would you like to talk about the mentorships?
Yash, you want to do it? Should I?
Sure. Yeah. So, thank you to all the mentors for working with Rian and myself. The applications are now closed. The offers have been submitted, and we actually have 3 mentees for 2 for Verizon and 1 for the ILET project, and they've already started work on these projects. So thank you to all the mentors once again. And if any other projects would like mentees, please reach out to us and we can get you started as well. So
Great. Well, thanks to you and Rian and Sal and everybody else who got that together, and particularly to the project maintainers that will be volunteering their time to do the coaching.
Yeah, I do want to say there was an email from one of the maintainers just today asking when they'll be able to reopen the mentorships because they had so many good applicants and they're looking for more. So that's a really, really good sign. I'm excited to see the next batch of projects.
Fantastic. So talking about tech talks, Łukasz had to wait a good deal of time to get into an open slot, so appreciate your patience on that. The rest of the calendar for 2025 is still relatively open. Towards the end of last year, we were starting to actually double up on tech talks, and that can be a lot to consume in one meeting. But I think we've got less pressure in the pipeline right now. So if you are connected to people in academia, doing research or other maybe interesting things that are just reaching productization, please reach out to Fritz for those. Anything you'd like to add to that, Fritz?
To
Mike,
talk
you
to
got
folks
your
and
hand up?
organize more talks. I think only next meeting is already something scheduled. The rest are indeed open.
Great, and I know we've got FOSDEM coming up, so there might be some talks that happen there that maybe we could bring back into the TAC for those who can't make it to FOSDEM. Mike?
Yeah, I was just going to remind people that as well as these tech talks, which is a great way, particularly as they're recorded, to let people know about what you're doing, we can organize webinars for sort of general, sort of outgoing rather than sort of more interactive, which we host on the CCC website. And, we're always very happy to have suggestions for those as well. Or even if you've got, stuff you've published on your own website that we could link in, which is, not just a pure product sort of pitch, but is, more general, then those sorts of things that we absolutely also love to be able to host on occasions. So do think about that as well as webinars, which as well as the tech talks, which are really useful, but they're not the only sort of mechanism for spreading the word. That and blogs and everything like that as well. That was all.
Great. And one of the recurring things, so usually we have about 3 different types of topics in these meetings, and one of them is something about projects. And we have a big enough project portfolio now that I think every month, roughly, we will have project updates to hear from. That's an opportunity to check back in with the project, figure out what kind of help they need, and what kind of interesting work they've been doing. And so we're going to get that schedule ironed out. We had several join at the beginning of 2024, so we need to spread those out for their for their reviews. All right, Rian, would you like to introduce this topic?
Yes, I can start it off, and Mike will probably chime in as he proposed it at the governing board meeting. So at the moment, there is a proposal in front of the governing board that we want to make antitrust policy training, because we discuss it every meeting and we say, please reach out if you have any questions, but to make sure that everybody know what it's all about, we want to make people aware about the training, but we ask the governing board to vote on making it a requirement for the officers of every officer in CCC, like the TAC chair or the outreach chair, co-chair, as well as all of the governing board, to make sure we are on top of the topic and make sure we do not violate any of these requirements. And same thing, if we pop over to the next slide about inclusiveness training, we also want to ask people to look at these, and we're gonna, as a CCC, if the governing board approve it, which I expect they should, require anybody that speaks on behalf of the CCC must have gone through the inclusive speaker orientation training, which is very good. And then at least one, but I would recommend 2 or both the other ones as well for educational purposes. These are about all of them about 1 hour each, and so it's a nice Friday afternoon. Don't want to do real work type of educational. You also get, if you sign in via LFX, you also get a badge on your LFX profile to show that you have taken the training.
How dare you, Rian? Not proper work, but I know what you mean. I have to say they are very good. Having been through so many different trainings over the years with different companies, I have to admit that I'm somewhat skeptical about these sorts of trainings, but actually these ones are absolutely excellent, and I'm very pleased that I need to update, and there's one I haven't taken, which has come out recently. I'm looking forward to taking that. And the antitrust thing, it's one of the great things about working in this environment. Typically, we wouldn't be able to have the sort of conversations we have in a standard meeting if it weren't for the LF antitrust rules here. Things like the fact that, we have the Linux kernel SIG, and we have folks from Intel and AMD and ARM and RISC-OS and NVIDIA all doing technical stuff in the same place is something that is very difficult to happen if we don't have the antitrust stuff. So it's really important for you and your companies that you understand this stuff. So again, heartily recommend that you take the training if you get the opportunity. And hopefully we're going to be making people do it who are officers. But yes, sorry.
Yep, no, that's great. And then with regard to these trainings, I was reflecting as you added this slide here that the composition of the TAC has completely turned over since the first time we went through this. But going back maybe 2 years now, it was just part of the practice of what the TAC did, that if you were a TAC member, you made sure that you were familiar with the course material here. And something that I learned from this is that this impacts the health of the project. So you have people come in and offer bugs or patches, and there's a lot of sort of unconscious things that happen with how those interactions happen. So, and the training made it clear to me how to make those things a smoother process. So it's a sort of selfish interest in there as well. All right, and with that, I think we've gotten through all of our announcements.
Sorry, can I just
And-
one final thing on that, if I may,
Sure.
which is particularly we have a very large group here, which I'm really pleased about. Please remember the code of conduct. If at any point you do feel uncomfortable about any of the interactions you have here, there are reporting mechanisms which we can use, which don't necessarily mean that your name comes out or anything. But if you think we could do a better job, we want to do a better job. So please let one of the appropriate people know. That could be me, Rian, Renu, Dan, Yash, or Emily or Nelly, who are our chair and co-chair of the GB as well. Sorry.
Yep, and I think we are due to have some more discussions on this stuff, because that's something that we've done in the past, and we haven't done that for probably a couple of years now. So look for an agenda on that in the coming months. All right, with that, workload identity. This is something that we always claim as an important advantage of confidential computing. Probably we don't claim it often enough, yet still we might be overly optimistic about the practical ability to make use of this feature. And Mark has raised this on the mail list. There's been some good dialogue on the list already from Diona and others. And I will turn the show over to Mark here to guide us through the problem space.
So I had a bit of a meeting reshuffle at work, so I'll have to drop in 10 minutes and then I'll rejoin at the top of the hour. So let me see how much I can cover in 10 minutes. So majority of
Well,
what
would it
needs to
be-
be,
Instead of splitting up the conversation, would it be better if we just deferred this to later in the morning and let
I
Caroline
can
go
do at
now?
the top of the hour. I'll have another half hour then.
So I really want to be here for this, and I can't do it at the top of the hour because I've got to lead a team meeting.
Okay, well, maybe we can start now. See, like
Okay.
I can cover a lot of ground in 10 minutes, really. So, okay. So, majority of what needs to be said has been shared with the mailing list, and what has been shared is sort of my summary of the problem. They're linked to a scenarios document in our musings under GitHub, and also a link to something that's going on at the IETF at the window in the workload identity working group. And the high order bits there is that the and I've been saying this for a while, that when we think of confidential computing as solely a data and use protection technology, we're sort of missing the forest for the trees. And data and use protection is an enabler, but it's an enabler of something far bigger and far more important, and that is you can tell with absolute certainty what code is executing, what secrets it holds, what inputs it may have received, and also have certainty that it was that piece of code that generated the outputs in question. And now the other thing that I've been saying for a while is that the majority of the customers for confidential computing are going to be regulated industries. And then the regulated industries will listen to the regulators and do what the regulators say. And regulators typically speak in a technology agnostic manner. So when we'll say, you need to harmonize human and non-human identities, for instance, well, the industry might just go to SPIFFY and meet a lot of those obligations, but without the benefit of the true security guarantees that a confidential computing could deliver. Now, there has been increased interest from regulators, this is critical, across the globe and also across several industry bodies in establishing some guidelines around this general area. Notably, you will see organizations from Singapore to Luxembourg, like government organizations, basically saying we actually want to understand what happens, in the shared responsibility model between the cloud service provider and the code owner. Then you will see bodies like the Cloud Security Alliance saying you need to now protecting data in use and also harmonize human and non-human identities. And then you have the European Cybersecurity or Cyber Resiliency Act, which is now demanding that organizations keep track of what code they have, what basically digital logic exists, and that is very encompassing. I guess in typical EU manner, they lead with regulations. So now, what does confidential computing have to offer today? Mostly, you execute a compute workload, you attest that you're running that workload, you get a key. You then use that key to decrypt some data that's stored in decrypted fashion on some store, and then you go from there. You can do quite a bit with that, but that is not how you can take a typical cloud application written in JavaScript or Python and go and migrate it into the cloud and know that data is protected and used across step functions, Lambda functions, notification queues, right? So, and what's more is all workloads, and now that we have agentic AI, that's another one. We would like to know what code is there, what code is allowed to access what other code. We could build the entire ecosystem on top of that. So now, if you look broader in the industry, SPIFFE uses node attestation, which is kind of at cross purposes with confidential computing because we attest workloads, not nodes. You look at Whimsy and they're saying, well, your measurements are too fragile. We can't really work with you right now because, again, there is no integration between the verifier, confidential computing verifier, and the IDP. So again, something I've been saying for some time, but now becoming more widely recognized. So what I have proposed in and I apologize, I'm speaking fast because of the time window and the fact that there is a lot of information to convey, so kind of a brain dump here. What I proposed is that the TAC consider dedicating resources to the workload identity problem so that we can work it now. I can represent a regulated institution, and I'm sure others on the call can think of their own use cases. Right, so it could be done under the auspices of the attestation SIG. My recommendation would be probably to stand up a separate SIG because attestation has been very busy and has a lot on its plate, but that's certainly up to discussion. And that we basically treat this, and this is the probably I want listeners to carry this as the most important statement. We need to treat this as an existential requirement for the success of confidential computing in the marketplace.
Okay, that's a great setup for a big problem space. And it was, I think Nathaniel saying that you wanted to be around. Is there something you want to hit? Well, we still have Mark here for the first part.
I am working on a project in this area. I'm not prepared to talk about it publicly yet, but it will be coming shortly.
Okay.
Mark, I'd love to pick your brain.
Okay. You can find me offline quite easily.
Yeah. No, we're friends in all the right places. Thanks.
It's good. Alec?
Oops, sorry, pesky mute button. I particularly enjoyed the link that Yash sent us as a response to Mark's mail. It feels like the use cases that they have outlined in the link and workload identity use cases there on IETF has a lot of overlap. I see Yash is on the call, so I'm not going to take up any more bandwidth. Yash, if you have a comment here, I'd encourage you to make it. But it just feels like there's a ton of overlap in the use cases that I've heard Mark discuss in the GRC SIG and in this web page that Yash pointed us to.
So I believe what I shared was the working group draft that they had come up with. So I was just resharing what I had found. I don't have anything else to add.
Do you mind
Sorry.
putting that link in the chat to save us all the lookup time?
Sure, let me find it
Okay,
quickly.
thanks.
I've got it right.
From
Yeah, I'll go
Whimsy
ahead.
group?
Right
So
now,
I will also mention that the consortium is not going to solve this on its own. So this will require collaboration with existing, efforts in the industry. So perhaps we can form or reach out to SPIFFE folks to see if the two approaches can be reconciled. We should certainly be more active in our interactions with Whimsy. I think I've been attending their meetings. Other folks on the call have been attending this meeting, but it's been sort of fly on the wall type of thing, where we, could try and convince them that there is a higher synergy than they recognize to date. By the way, I will mention that if you read the RATS architecture, then you will walk away with exactly the conclusions that Whimsy walked away with, as in like we can't make the two work together right now. But it's still very early days, so it is quite possible to change their mind, but it would require us to make a compelling case and prepare to change some minds.
Hank?
Hank, you have your hand up.
Okay. Yeah, hi. Sorry, no, I haven't spoken up for.
We're having problems hearing you now, Hank. I'm really sorry.
That's what happens when your microphone gets out of practice.
Gotta stretch first.
Never a problem for me.
And again, folks, I apologize. I need to drop for about a half hour. I guess I'll watch the recording later, but I'll rejoin.
Okay, we'll switch topics while you're gone anyway. I think maybe just a couple quick thoughts before we switch is that if we want to take up this as an agenda area, we do need to start to tease out what are actionable areas so that we can kind of move in a concerted direction. And if we want to get to a SIG, my guidance will be that let's have a few of these discussions in the TAC first before we really understand what it is we would want to splinter off into a separate group.
Yeah, I'd agree. I think we want to talk to the GB about this as well. We mentioned it, as you know, to the GB yesterday, Dan, but we've got more SIGs means we need to make sure we can staff them and do real work with it, which I think we can, but we just need to be careful about overreaching ourselves.
Yeah, and before we create any SIG, a necessary part of that is coming up with a charter, which also implies like we know what we want to accomplish with that group. Definitely a lot of important space here. I do believe that this is a very significant thing, and we'll come back to it probably around the top of the hour when Mark rejoins. And Caroline, if you are ready to go, we can switch tracks into the project proposal.
Thanks, Dan. Yeah, I'm ready to go. Can folks hear me?
Yes.
Perfect. So for anyone who I haven't met, my name is Caroline. I work in Microsoft in the core operating system team. And I had the chance to meet some of you and talk about our project late last year. But so I'm excited to be back and discuss this a little bit further, see what questions some folks might have. To give maybe a brief summary of what has been discussed in the past, OpenVMM is a project that was incubated in Microsoft, and we open sourced it in October of last year. And it is, hopefully the name describes it, it is a VMM, a virtual machine monitor, that is meant to have several use cases, but the first exciting use case we have is running it inside a paravisor, which is a layer of code that runs within a VM and provides that VM different types of services. For confidential VMs specifically, it can, oh, and thank you, Dan, that's great. It can provide device acceleration services, same as it can provide that for non-confidential VMs, and debugging capabilities and a bunch of other great stuff. But the particularly maybe interesting one that we've discussed in the past is for a guest operating system to run within a confidential VM, it needs to have some knowledge of the confidential computing platform, whether that's AMD SCVSMP or Intel TDX, or even ARM CCA. It needs to have those changes, and sometimes those changes take time to make their way upstream, and then their confidential computing is always evolving. There's always new technologies, and so they're always changing, right? There's always new things that need to be ingested by the guest. And so the pairvisor can give customers the option to not necessarily have to rely on having the latest guest with the latest changes to take advantage of those like latest advances in confidential computing, because the pairvisor itself kind of acts as a compatibility module. That's actually what the HCL stands for. It's compatibility layer. And so it can be that kind of middleman and provide that on behalf of the guest, so the guest doesn't have to worry about having these changes to leverage these functionalities for confidential computing. That being said, OpenHCL can in theory be leveraged by, say, a fully enlightened guest, but there is no use case today that leverages that functionality. But yeah, just wanted to clarify, it can in theory be used by that. And so here in this diagram, we can see there is the VM, which has the guest OS and the OpenHCL layer. Of course, here it's big because we've put in kind of the blocks of services that it provides. But if you think about a VM, of course, OpenHCL would be like a very thin layer. Like it's way smaller, for example, than the average guest OS. And as we can see, it has OpenVMM, which is the VMM, and it runs on top of a very, very small Linux kernel. This is also open source in its own repo, and runs basically everything we need so that OpenVMM can run. Again, OpenVMM could in theory run on top of other environments, but the one we have today is the Linux kernel. I'll pause there. Any questions, thoughts?
Right, so far reminds me all the stuff you said before it hasn't changed, so that's good. But of course, not everyone will have been here for the previous ones, but sounded good.
Hank?
Yeah, sorry for before. I will pick that up. Marcus back. Yeah, my device died, and there was basically no indication about that. And but the OpenVMM layer here, concerning that, this is basically a BMC for VMs. What you're building here, is this a convenience co-located function that is outside of the guest OS that helps you manage it and do all the administrative work you typically want to do, like VTM provisioning and all that? Is this basically a BCM but virtualized?
I'm sorry, what is BCM in this context?
I think it's a baseboard management controller. It's basically the computer in your computer that you don't own and control.
Oh, I'm not sure I've heard it described that way. It doesn't sound necessarily wrong to me. Basically, it, you know, for a traditional
Caroline,
host. Oh,
sorry not to
sorry.
interrupt, but you were saying BCM. I think
BMC.
he's saying
the
BMC,
BMC
the baseboard management controller. I don't think this is baseboard management controller. Did that make sense?
Okay, if it's not, it's fine, because it looks like there's this additional uniform entity in all devices that helps you to configure and steer some of the device layout, which a BMC does. But if it's not the same concept, it's fine. Thank you.
No. I was just trying to clarify. You might have confused Caroline by just switching those two letters, because BCMs and BMCs are completely different things. So
yes.
He was asking about a BMC, which is, the thing on the node that lets you upload new, CPU firmware to all the nodes in the entire Azure fleet. This thing runs inside the VM. So I didn't mean to jump in the middle here. I just wanted to clarify that transposing of letters there for you, Caroline.
Sorry. Yeah.
Thank you. No, I really appreciate it, Alec.
Yeah. So it's not directly a specialization of that for VMs, and it's a different scope. Okay, thank you.
Exactly, and maybe tying to something that some people might be more familiar with. When we have just traditional VMs in the traditional virtualization world, the host OS normally has a VMM, right, which manages a bunch of things for VMs and provides a bunch of services for those VMs. And so this idea of having this paravisor layer is we actually move, like, where it's not necessarily even doing something new, it's rather moving what the host used to do and the host used to provide and moving it to within the guest VM. And the reason for that is especially relevant for confidential VMs. I think there's a lot of benefits to that, but for confidential VMs specifically, we know that the host is outside of the trust boundary of the VM. So if the host is providing you all these things, you kind of have to be hardened against all these things. Whereas if a layer kind of within the VM itself is providing them, it kind of makes the thread model a lot simpler. Of course, this is within your TCB, this layer of the paravisor. And so, again, just for anyone familiar with the VMM in the context of a host OS, the idea here is we take that and we run it inside the guest, and that has other benefits on top of confidentiality, like, for example, just better performance. If we think about devices, for example, instead of having to go through the path of a host, we can essentially attach a device directly to the guest, but without the guest OS necessarily having to have the right drivers. For example, like a new NVMe driver, again, this layer can take care of that. And that's just faster than the host. It's a faster path.
So thank you for reminding us, or for those who haven't seen it before, introducing the architecture. Why don't we go ahead and walk through the proposal? So for expect tech members are familiar with the criteria, but that is out on our governance repository. And Caroline has filled out the template of questions here. Though I see Ram and Mike have their hands raised. So Ram, why don't you go ahead?
Yeah, thanks. So Caroline, our question is, this layer is not provided by the CSP, right? Is it something that is packaged by the distribution? How does this work?
Yeah, no, that's a great question. This is something that is meant to run within the guest VM. So it could, in theory, be provided by several components, meaning it could be packaged, for example, as part of the guest OS image. And I think we definitely have explored that, for example, in our confidential VM offerings in Azure. We have explored that. But the way it is used, at least today, it is provided by the host OS, meaning all of this is packaged into a small file that the host OS provides. The same way it, for example, might provide like the VM UFI image when launching the VM. That being said, that's just the configuration being used in Azure. There's no reason why, for example, if someone were to want to take this and run with it and build their own thing, they could make it so that it works in a different way, and it's provisioned by a different component that is not the host OS. Like, customers, for example, might feel very strongly about saying, I want to provide my own OpenHCL image.
So
and
can I?
And that is definitely possible.
Yeah, can I add to that? In some ways, it doesn't matter how it's provisioned, as long as it's measured and attested, and as long as it's open source. And having it, open source and part of the CCC would be one way of doing that, because whoever it comes from, as long as you've tested it and checked it, you can have a trust relationship to it. So that's a good thing. Fair?
So I agree that it doesn't matter from a security perspective, so long as we can measure and attest it. I am curious now that the question was raised, if one of the main use cases is I have an unenlightened guest, what is the easiest way for an unenlightened guest to be able to make use of OpenHCL?
I think it's not needing to know that it even exists, which is kind of how it works today in Azure. So the host OS will take care of a bunch of things when launching a VM and loading this into the right region of memory along with a bunch of other configuration it does before the guest OS begins to run. That's the easiest path. Again, in terms of just compatibility and the guest not needing to know, not needing to like do a special handshake or anything with it. This actually loads right before the firmware, the UEFI firmware. So there's even, stuff happening after this has finished loading. And then before the guest OS begins to run, the UEFI layer runs. So this is right before then. So again, the guest OS doesn't even need to know about it in this mode. There could be other modes that actually want to, but yeah.
So if I do have an unenlightened guest though, and I just want to be able to use would I need to create a new guest image file that?
No, you can take an existing one. Like we can take an existing Windows Server 2019 image, launch a confidential VM, and we tweak a few things in the host to tell the host, hey, when you launch this confidential VM, make sure you load this image that is going to provide these services to the VM, but the guest doesn't need to change or have any modifications.
Okay, great, thank you.
Manu?
Caroline, it's a very interesting topic. You said you guys discussed supporting this in Azure, and I kind of understood that it's not supported now. Are there plans for you to support it in the future, or to offer it as an option in Azure?
Yes, no, that's a great question. When we actually get sometimes a lot of confusion around that, because if you read about our project, it says it supports TDX and it supports SMP today. And this is true. Like you can take this code and run it inside a TDX confidential VM yourself. And so that's very exciting because that took years of work to get to that point, and a lot of collaboration with Intel and so forth. But then you go to Azure and you see we have TDX confidential VMs in preview. Are they using this? And the answer is no, not today, because the message we're trying to go with is not, hey, we took what is running in confidential VMs today and we open sourced it, but rather we're building it in the open, meaning the layer of code that is running in confidential VMs in Azure today is essentially this, but a very old version of this that we chose not to open source because it just wasn't so interesting to do so. Rather, what we're saying is all future confidential VMs in Azure are going to use this, and we are building it in the open. And so, for example, OpenHCL, just to say TDX as the example, it already has the TDX functionality, and we're essentially adding a few other pieces that are maybe Azure specific related to attestation, or getting it to a certain point in reliability. And very, very soon, we'll launch the next generation of TDX confidential VMs, and they will be using this layer. So it's not being used in Azure for confidential VMs today, but it will be for other future ones, which are coming very soon. I can't speak to specific dates, but it's definitely this year. And this is being used in Azure today for non-confidential VMs. But yeah,
Can I just
I think your question was
a,
about confidential.
may I make
Yeah,
a point?
go ahead.
As this is a recorded call, you might want to say that to the best of your knowledge, this is the plan, but you can't make promises, commercial promises on in this sort of context, unless of course you can. But I'm having been in this sort of situation before, you might just want to cover your back a little bit.
Yeah,
I don't
no,
think
thank
you
you.
need
I
to be worried
appreciate
about
that.
covering your back, but yeah.
And maybe I should also specify, because of the date and everything, like we're in early 2025. We're very excited about new confidential VM SKUs in Azure coming out later this year. That is within our plans, and what is for sure is maybe we can't maybe make promises on when exactly those will be launched, but they will have this new layer. This new layer is like we're making all our investments for confidential VMs in this open source code. So there won't be like other confidential VMs that will come out that will have the old one that is not open source. Like we want to build this in the open.
So just to clarify, we will be able to have our own guest OS and then launch it with OpenHCL and with OpenVMM within our own guest OS on TDX in Azure in 2025.
Yes.
That sounds
let's
like
not
what
worry
it
about
should they're
dates,
hoping.
but yeah.
Sounds
Yeah,
great.
exactly.
Thanks.
Okay, Ismail?
Yeah, hi Caroline. So my question is, I'm thinking because this will be the first piece of code to be laid out in the address space of the VM. It will naturally be part of the initial launch digest. Either it will only capture the paravisor code, or it will be this plus some other pieces of code. But this is a lot of code. It will need to be updated, which means the measurements, which is going to start this chain of trust in the CVM, is going to be updated frequently. So I'm wondering, the CVM users, should they expect to consume the reference measurements for this? Are they going to be made public? How do you see the updates of these reference measurements happening?
Yeah, great question. I'll put this in the chat, but we have a lot of documentation on how attestation happens for existing confidential VMs with the older version of this paravisor. And it is, of course, as you say, part of the chain of trust, and it needs to kind of go back to the hardware-based root of trust. So it needs to be signed by the platform, for example, by AMD's PSP. So we expect parity with our existing flow, meaning the way customers can attest and what they can look at, what information they can see as far as how this is updated, and for example, what claims they can see about the OpenHCL, meaning like it's this version, it's Azure compliant, for example, and how they can tweak that in your own attestation policy. So for example, some customers might say, I want to make sure that debugging is off for the OpenHCL and or their paravisor, whichever version it is, or it needs to be this specific version. All of that is something customers choose, and all of that flow works today for the existing paravisor. So it won't be like it'll be at parity. There won't be anything less. We'll have that the way it works. So I'll put that in the chat so folks can see. But I think maybe the point you're driving at is, well, now that this is open source, what's the story reproducibility? That we're still working to figure out. We have had some folks reach out since we've open source asking about what about reproducible builds? When is that going to come? And it's certainly in our roadmap. It's something we're working on. We just don't know what that's going to look like yet.
I have to say, this is the sort of thing that mentees or interns can be very helpful with helping work out if you are a CCC project with an intern. Just putting it out there for a mentee.
Yeah, I have a quick question that might be related to the approval process. I mean, not an impediment, but just a clarification. Is that it sounds very similar to Coconut SVSM, right? Why have you created something different instead of collaborating with an existing project? What kind of features you are bringing to the table that are not available today?
We are collaborating with them. We've been collaborating with them for over a year. Maybe it's close to 2 years. And we think Coconut SVSM is fantastic. But we do aim to solve a different problem. A lot of you'll see there's some functionality that we have in common, but a lot of the functionality, if you actually look at like a repos and the services provided, a lot of it is different. But we're definitely collaborating and excited to see if there's a path we can explore to convert your projects and yeah, actually like literally combine them, like have one leverage the other in their environment. So we're definitely aware of that project. Does that answer your question?
Yeah, sure. Great. Thank you.
Alec?
Sorry, I'll go. Last time when Caroline spoke, she gave a pretty good answer about Coconut, and she said that Coconut is for enlightened OSs, right? The idea is the OS has to know that there's an SVSM that it can utilize to do secure operations to access the VTPM, for example. This Open HCL, Open VMM, is designed for OSs that have no idea that there's an SVSM there. They're just using traditional ways to access physical hardware on the host, and they have no idea that there's an emulator underneath that. But we want to insert HCL in the middle because these naive, unenlightened OSs blindly trust the host, right? And Open VMM is there so that that blind trust from the host OS, from the guest OS, sorry, goes through Open VMM so it can be hardened before any interactions with a potentially hostile host. So that I think that I'm just remembering that from her last talk. I hope that was accurate. If not, Caroline, please correct me. I just wanted to kind of encourage the conversation, like Dan said in chat, to move away from a deep dive. And Caroline, I hope you'd be willing to come back and have another Q&A with this team. It seems like there's a tremendous amount of interest. I'm especially interested in open source, and reproducible builds. I don't know how that would help the open source community. I understand how that would help Microsoft and Azure, but I don't understand how it would help the open source community. I'd like to dig in on that, but I want to put a pin in that conversation and turn this particular talk back into, hey, let's get a vote on this thing and let's get this approved.
Yeah, well said, Alec. And I think one of the things Caroline mentioned in passing there was that the intent of the project team there is to develop in the open. And I think it's great that this is being offered to the consortium while it's still in a big growth arc, so that other people from the community can join in and help shape the outcome of it. Ron?
Yeah, sorry, one quick question. I don't think I entirely understood the answer that I got earlier. So the question really is, if I am a customer and if I want to build my own image, should I be building OpenHCL inside my image, or is that image coming to me from the CSP? I think that's what I'm trying to get to.
Which image are you referring to?
If I'm building my
guest
own
image.
unlightened guest image, right? I have an unlightened OS with a guest image, right? Do I have to package the OpenHCL in my image, or does it come from somewhere?
I don't think you need to package it within the guest OS image, but rather you can package your guest OS image and the OpenHCL image together in a single file. And then that is what gets loaded within the VM.
Which is, I have to do it either in any case, right? I have to, it's not somebody else provides the image while the image is running. It is, I have to have the image in some format and provide that while instantiating my guest on the host.
Yes, if you as a customer or as an entity launching a VM, if you want to, you have to provide it and package it. But or the other option is you can just rely on the host and say, hey, host, just give me, I'm going to launch a VM. I want to use this guest OS, and put the latest and greatest OpenHCL in there, and then you kind of rely on the host to give that to you. And of course, it's all attested, so you can know it's trustworthy. But it is both options. You don't have to package it yourself if you don't want to.
I see. Okay, got it. Thank you.
Okay, so let's move then into the proposal. We can glide over the project description. We just had a lot of that. So some of the things that are important for us to consider are the license, and if there's any sort of obvious legal impediments. Once, if this goes through the TAC, then LF Legal takes a look at things. We don't actually look at this from as though any of us are lawyers, but understanding the open source license is within our domain here. So do you want to, well, I guess I don't need to hand it over to you, Caroline. We can all read here. This is an MIT license that's considered a standard open source license. Anybody has concerns about that, they can speak up. We also like to know that people aren't just kind of hoping that a project continues if they hand it off into the community. So it does have backing here from Microsoft, and from what Caroline's just said, it's an active part of product planning. So that sounds like it will be well resourced and not left fallow, so to speak. We just talked about the connection with coconuts, and I think I saw Jurgen earlier. I'd still be on, but yes. These provide complementary features. Just discuss that. Code of conduct. So typically our projects are recommended but not required to use this particular code of conduct. I see that you've got the Microsoft open source code of conduct. I'm not familiar with the differences in these. Is that something that you can speak to?
No, I'm also not familiar. I would say this is what was recommended to us to use from the open source ecosystem team, sorry, within Microsoft. I can definitely take an AI to look at the differences and summarize those for the group, but I mean, I would expect they're not very different.
I would be surprised if there are two. I think maybe just one little nit to look for is there's usually an escalation if there is a violation. And so if that goes up to Microsoft to be handled, it's just something to keep in mind as far as the parties that are involved. But I don't expect that that's a serious hindrance.
Hey, Caroline.
Yeah, I think so. That is in
here. I think we've got Stephen Wally as a resource that will help us one-on-one, Caroline. And I know he's super familiar with both the contributor covenant and the OSS code of conduct, the Microsoft OSS code of conduct. He helped draft it. So maybe we should go to Stephen and he's also a governing board member for the CCC. So he'll probably be able to give us some good insights, and then we can respond to Dan's excellent observations here.
Thank you, Alec. Totally agreed.
Okay, we've got URLs, active issue tracking. So dependencies, we added this just because, this is important to understand the TCB. So I appreciate that this was probably a bit of work to determine all of these. Could you talk a little bit about the copyleft implications, if any?
I don't expect there to be any implications that are very unique to our project. I think all, if not most of these are used by many other projects for similar use cases, and I don't expect we basically use it in any way that kind of puts us in a different position or that has different implications for our project. As of course, it being like a full-fledged VMM, it's a large code base. It does have a lot of dependencies. Most of them, of course, are the Rust crates, which is the first bullet point. We didn't list them out because it's like over 100, but
sure.
Yeah, I don't expect any different implications. Do folks here have
so my
concerns
high level
around?
Sorry to interrupt. I guess probably my high level question would be, the project itself is MIT license, and you have these listed, these GPL dependencies listed as runtime, which implies to me that these are not linked, and then that does not trigger a copy left. You aren't directly linking to GPL code.
That's correct. Most of these are runtime.
Okay. Thank you. Anybody else questions on the licensing?
Now, I have some questions about existing community and plans to extend involvement. We obviously are keen to grow involvement in this project, and I guess that's part of the reason that Microsoft wants the CCC to be involved. Do you have any existing plans for how to encourage involvement beyond Microsoft? Like, is it solely Microsoft contributors at the moment? And secondly, so firstly, is it solely Microsoft contributors? Secondly, do you have plans to extend that? And if so, how? And thirdly, is membership of the CCC going to give you particular help in extending that contribution base?
Yes, so we have had contributions from outside collaborators, which is really exciting. I would say the majority of the contributions are from within Microsoft at the moment.
That's
we
usual.
definitely,
Yeah, don't worry about that.
yeah, we definitely want that to change. And the steps we're taking in that direction is we're trying to evangelize this project. And for example, we'll be attending the OC3 conference, which is in March, I believe, and looking to attend others where we can talk about this and encourage people to come in and check it out and participate and contribute. We are also working with a lot of partners from other companies like Intel, AMD, ARM, Red Hat, and really anyone interested. Like, we have an open communication channel. We've had a lot of meetings with these partners. Also, if partners prefer to have meetings internally, we're open to that. Partners are okay with having meetings that are public, we're open to that. So we really want to kind of accommodate because partners might have questions that have to do with like internal products that they haven't publicly disclosed yet, or stuff like that they want to ask about. And so that's why we have that option. And we've definitely been meeting with a few in the past couple months, but we're looking to expand that as much as we can. And so, to I think your last question on the CCC is we're definitely looking for mentorship and encouragement to see how we can further expand that. But yeah, I think you looking at the list of contributors, for example, a lot of them are from Intel. Intel has been contributing a lot of really great stuff in the past few months.
It looks like it's a flourishing project at the moment, which is great. If we can help nurture it, and if it helps nurture promote adoption, I'm all for it, honestly.
Yeah, I think that's probably the central question that Mike's raised here, is the interest in growing the community outside of the original contributors. And so I hear Caroline saying, yes, that's definitely a goal. We used to include in the project proposals like a default governance framework. The Linux Foundation stopped requiring us to do that. I wonder if, I haven't read through this contribute.md, but do you have a sense in mind of a path for contributors to become maintainers?
No, yeah, if you actually look through this, you unfortunately won't find any documentation to that effect. And that's because just purely we're a little early in our thinking there and how we want to formalize that. And so our thinking was, let's open source and see what feedback we get from the community. And then once we have a little bit of that input, we can kind of formalize our thoughts and our process of, okay, this is your path to becoming a maintainer. But we don't quite know what that is. And so it's kind of a chicken and egg problem of like, we don't even know what to expect once we open source. So we didn't want to put like a formal, this is how you get there in our documentation quite yet, but it's definitely in our plans. It's just not something we've formalized yet.
Okay. And just to maybe reiterate then, is your project community interested in developing maintainers from other companies?
Yes, very much so. I think just the path to how to get there is what we haven't figured out yet.
Okay, great. I think that brings us to near the end. So you want to come at incubation level? Seems appropriate to me. And then I think Alec already dropped this in the chat. Any other questions from anybody in the community or voting members to better understand the fit for this project in the CCC portfolio?
Just so I understand, Dan, are you hoping to bring this to a vote today?
What I shared with Caroline is that typically our process has been we introduce in the meeting and people have time to ask questions and then reflect on the answers, and then we'd probably bring it for a vote in the next meeting. But each project proposal is different. So if people feel ready to go today and somebody wants to make a motion to vote, we could do that.
And it's not the first time it's been talked about in a TAC as well, of course. So, yeah.
Right. So
yeah, I was about to say that we already talked about it last time. So I would personally see no issue on voting.
Are we, well, the other question is, are we quorate? That may be a bit of an issue.
That's a good point, yeah.
Nathaniel will be back. Oh, he should be back now. So that helps us in terms of numbers. But we might want to think about that.
Yes, we are.
Oh, okay. Wow.
I think Catherine mentioned that she was stepping out in chat. I don't see Nathaniel back. So we still have quorum, I guess, but we're down those two individuals from where we started.
Well, we don't need to do it quite now. If we think we are going to get people back, it's always nice to have as much consensus as possible. So we have another 50 minutes in the meeting. So if we want to do some other things and maybe come back to it, that would be my suggestion, but we don't have to.
I think maybe to include as many people as possible, we might also move this to an email vote.
Oh yeah, that's also.
We can consider that doing that as well.
Yeah, good point.
Just see if we can just look at the checklist here and see. Okay, so Paul, would there be additional things that you need considered before we move to a vote?
From my point of view, no. I'm already quite familiar with the project, so I would be more than happy to vote.
Okay. Yash?
Yeah, we can proceed with the vote if everyone's okay.
All right, well, it sounds like everybody is satisfied that is here. How do people feel about voting over email so that our colleagues who had to step out can still have their voice, or waiting until next meeting when we might have a different subset of people attending and not attending?
Well, I mean, we can start a vote now, and those people who are happy to vote can do so, and the rest can vote via email. We can have a split vote. I think that's okay, Rian. I don't see a reason why we shouldn't do that.
Yes, we can do it like that. We just first need a motion and a second, and then people in the meeting want to vote, we can, and I'll roll the rest over to a email vote.
If your statement was a motion, Mike, I'll second it.
I can't propose because I'm not.
Okay, then I'll propose the split vote exactly like you mentioned it, Mike. I think that my view is that since Nathaniel wasn't here for Caroline's presentation, I'm not sure. I think it would make sense for him to express a view, but he's going to need time to review the materials and maybe.
And it's recorded as well, of course, so that hopefully, and he can always get in contact directly as well, of course.
But just wait for him to come back to the meeting and say, "Hey, we had this long discussion. You missed it. What's your vote?" I don't think that makes sense. But those of us that were able to participate in the discussion, I think now would be a good time to vote, so we can do it while it's all swapped in.
Do we have a second?
I can second.
Yeah, same.
Thank you, Paul. The floor is open to vote. Nathaniel,
Okay, cool.
it's not in. Paul, what can I put down for you?
I vote to approve.
All right, and Catherine is not in at the moment. Dan, what can I put down for you? Thank you. And Alec, as you proposed, I assume it's a yes.
Yep, I'll vote yay.
Thank you. And Yash, what would you vote?
I vote to approve as well.
Thank you very much. We've got 4 votes for approval. I'll send it out to the mailing list and request further votes to get it over the
Rian, I
line.
also vote yes. I think that's already 5
Oh.
then that we need.
Okay, thanks. And I've got Fritz. I missed you on my list. Fritz
No
also
worries.
vote.
No worries.
Fritz also votes yes. That gives us 5. Congratulations. This is approved. We will take it to the governing board vote to get it approved there. And then Caroline, I will work with you to get the administration sorted out.
Yeah, there's lots of data administration, which means we can't officially approve it in the GB until that's done. But Microsoft has done this before, so it shouldn't be too difficult, hopefully.
Awesome. Well, thank you so much. And we will, Alec and I will meet with Stephen to talk about the difference in the code of conduct and kind of come back with an answer very, very soon, maybe tomorrow, if not next week.
Perfect. Thank you very much, Stephen. And sort of hearty pre-congratulations. And we appreciate your time and your interest in bringing the project to us as well. So really very pleased. Thank you.
Great news, Caroline. Now the bad news. I'm going to invite you back for a tech talk to answer all the open questions that came out during your pitch. I thought there were some really good questions there that deserve a little bit more discussion.
Awesome. Thank you so much, Alec and everyone.
Yeah, thank you, Caroline. I know that putting together a project proposal and getting internal stakeholders aligned is not a small ordeal. So I appreciate you taking the initiative and all the extra effort it took to make that happen.
The fact that we have approved, I'm not going to send out the email vote unless we want to collect more consensus, but I think we don't need to. Any thoughts, Dan?
Send the individual emails to the TAC members who couldn't be here so they can still express their views.
Okay.
Yes, I think it's important that they get a chance to vote. Yeah, thank you.
Okay, wonderful. I think what we should do here is respect our Tech Talk presenter and switch over to that. And then we'd normally allocate about 30 minutes for that. So that would still leave us for roughly 15 minutes at the end to kind of come back around to the workload identity topic.
Okay.
Unfortunately, I have the next 15 minutes and then I have another meeting. I'm sorry.
Yeah, that's unfortunate timing with your schedule kind of in and out today.
Well, we can pick again in 2 weeks.
Yeah, it's great that you've introduced it and we can kind of get the ball moving forward after that. Okay. I will stop presenting to give you the opportunity.
Okay, so let's do this. Can you hear me?
And see you,
And
yes.
see my screen. Okay, good. Thanks. Okay, handling window managers. Okay, cool. So yeah, we'll be talking about how computational compute as a thing can apply to other things we do in decentralized networks. So who am I? Hi, I'm Magic. I'm a co-founder of this company called Curious Storage Inc., which builds software for people providing services to decentralized networks. And previously I worked on this project that's IPFS and then later on that transitioned into work on Filecoin, which is this couple exabyte decentralized storage network storing real data for real companies. They also like doing weird hardware. But yeah, so that's me. I'm going to start by talking about what it is that decentralized networks try to achieve, just very briefly, and like in general what like all of this decentralization is about. Then I would jump into kind of 3 broad topics of what I think confidential compute can apply to, and then kind of about the runtime components that will be really, really convenient to have for us. So yeah, the main thing in decentralized networks is really kind of trying to remove the mapping of I want to do something with someone. It should be just I want to do something and the software figures out with who, or like just kind of removing all of the trust and like specific contract mappings and just doing the thing. So retrievals should be able to happen just with other computers on the internet, and storage should happen with other computers on the internet, and kind of same with compute. Obviously, specifics are between very and extremely complicated, but that's the broad idea. So essentially, the idea is that instead of trusting in more like legal contracts, the trust is put into software and kind of security of protocols, and everything else kind of happens by itself. So yeah, what exists kind of without trusted execution environments is storage exists in pretty good ways. Obviously, always can be better. I will get into how. Retrieval is really hard, and this is kind of like CDN style thing where it is really, well, I mean, it is basically been proven that it's not possible to kind of trust 2 Byzantine parties telling you that a retrieval of data has happened. With compute, there are some networks, but they are also kind of very best effort. So it's like nothing really solid. It's like a couple that already exist, kind of using trusted execution environments that are pretty good, but they're also not really coupled to storage or retrieval, so doesn't really form a good primitive. Now, so the kind of core thing we're looking for in these is they had this really powerful concept of now we don't really only have to trust, like if I'm a participant in the network, I can only trust my software and my computer, and I don't trust anyone else. But now with TEs, I can trust something that someone else is running on their computer, and it is a really, really powerful concept. And so it's kind of getting some broader themes of how that is applicable. And so one major thing is it's like possible to prove way more about what other people's computers are doing. Obviously, improving data confidentiality, that's like the more obvious one. And then also it gives a much better job to run compute jobs on other people's computers in a way that's trustable, because like the providers cannot tamper with that computation. And so I'll get into all of them, starting with the compute on trusted providers, which is kind of the simple case, kind of already a few companies exist implementing that in decentralized networks. So this roughly is gonna get something to run, start a VM container, whatever, give it some memory, network, cores, storage, all this stuff, and then get paid for used resources. Now, there are challenges. So network storage are more or less simple. And like the changes are mostly around resource use has to be measured for everything that is rented and paid for, because the kind of difference in those networks is that there is no legal contract between the client and the provider. And it can be really hard to kind of take a provider to court or get a refund or kind of do anything as a client to have a way to enforce getting all the resources that have been paid for. So kind of everything has to be based on very limited trust. And so network storage is kind of easy because they can be mostly measured through a proxy confidential compute VM. And then memory is generally also kind of easy. And I will add one thing. So if there are any questions, feel free to chime in chat or just raise a hand, and I should be able to see you. I want to keep this kind of open and with back and forth. But yeah, memory is also kind of easy. One tricky thing is memory speed matters, and providers can be something quite Byzantine in just like underclock everything just to a maximum degree to like save on power costs and anything. I see a hand. Mike.
Just to note that these are indeed difficult problems. Nathaniel, who I'm not sure is on call at the moment, and I actually put together some patents while we were at Red Hat around ways of being able to make estimates that you can trust to some degree as a client, and ways of doing that, which I'm happy to talk about on another occasion if that's something that's of interest to you or anyone else.
Yeah, amazing. But yeah, it's like all of the things like, course, like exact number of cycles executed, something approximating the amount of work needs to be known,
Yeah,
and then
it was
time.
ways of trying to get things you could trust, which were difficult for the host to fake, basically. So anyway, it's fun stuff.
Yeah, it's like short version. Performance characteristics do matter here a lot. But yeah, moving on. So that was like the compute. This is already, I believe already there are 2 or 3 different networks that are working with, at least at some level, with the common computational compute runtimes or like platforms. So like SNP and TDX is definitely not uncommon to see. But yeah, there is much more. So growing data confidentiality, this really applies mostly to storage networks specifically. And so the way they work today is generally providers store whatever they are sent by clients. And this is problematic in multiple ways. So yeah, like main one would be providers can see the client store. I see a hand from Alec.
Yeah, I'm just curious about your first bullet point. You say that encryption is often not enough. I'd be curious to hear you elaborate on that, but you can get to it.
Oh, yeah. So generally, like clients can encrypt their data, and they do most of the time, unless it's like a public data set that is meant to be public, but it is most often not the case. And so there are certain cases, like depending on your kind of regulation, like SOC 2, HIPAA, and GDPR have very different requirements, and often it's not enough that data is encrypted if some arbitrary party with no legal contracts can read that. And so there does need to be a way stronger ACL system that kind of makes it impossible for the provider that like the entity that is storing the data to have any kind of access to the bytes, even if encrypted. And it's something that could be fairly easily done with ACLs. With continuous compute. VMs acting as a proxy to storage, because then the VM can run a piece of software that is only able to establish secure communication with the client who has the right to read and write that storage. And the secure VM, I believe I have next slide. No. Yeah, so yeah, that's the order of the slide is right now the data is kind of sitting on providers. So very best effort. It's not possible to prove deletion. This is kind of bad, but with these, it is now in theory possible that if there is a TE that is the only thing authorized to really talk to storage, so hard drives and VMEs and VM hard drives with confidential compute capabilities. In theory, it's really possible to build a system where only the client has the right to read and write to the provider storage, and the provider, the only thing they can do is just allocate the space, and the hard drives would refuse to give them the raw data. And yeah, I think this is a fairly powerful primitive, especially for storage networks. And honestly, I also believe most of the pieces for that more or less exist today. The other really powerful thing this allows is proving data deletion, which without trusted hardware is just kind of ridiculous concept to even propose. Like, you cannot possibly prove that data has been deleted, but here, if you're going through trusted hardware, you as a client can actually know that that data is gone from that hard drive, and you can also have some pretty good level of assurance that the data has not been copied anywhere, because in theory the provider couldn't possibly access the bytes in the storage. And there are many reasons for that. Mainly, some clients really don't want their data, even if encrypted multiple times, to be ever read. And there are also some regulations, I think mainly GDPR, that really do require data to be removed when it's asked to be removed. So I see another hand, Alec.
You just answered my question. I was just thinking of, at the simplest level, if I create a key inside of a T and I use that to encrypt data before I write storage external to the T, the storage has encrypted data, but it's of no use to anyone unless I leak the key. If I then destroy that key within the T and the T goes away, that key is gone forever, and therefore the data stored are irretrievable forever.
Yeah, I don't think GDPR lawyers would agree.
Is that, yeah, if there are regulations that say, yeah, we're scared, we know you said you shredded the key, but what if the key unshreds itself and leaks? That I get. Okay.
Yeah, it's purely regulation. Working in kind of the cryptocurrency space, I am very familiar with how crypto works. I know it cannot be broken, but regulations say, but what if? And this is this kind of, if it says it needs to be removed and your clients say it has to be removed, there needs to be a way to kind of assure that. I also see a hand from Mike.
Yeah, so it's a question of who needs to know that it's been removed. In that case, I think I agree, because you need to proving that a key has been deleted is no easier than proving that a stored piece of data has been deleted, because you're trying to prove the same thing, basically. So unless you have a way of doing that, and I can think of at least one mechanism that's probably patentable that would allow you to do that, so I won't mention it on the call. then it doesn't make much sense. And even if you're using a TE, so proving that the TE has been deleted, unless you can prove that the key was never exported from it, doesn't really buy you anything, I don't think. So
yeah, like here, like everything hinges on the TE not being tampered with, obviously. And like if the TE software is correct, then the software in the TE should prevent the key from being ever leaked. And like this is the obvious assumption here. And yeah, I will go a bit into the assumptions about the security in a second. So yeah, going next. So yeah, ICLs are also a very big theme. Generally, clients oftentimes just store data and then they give access to other parties to read that data. This is generally true with like everything like machine learning data sets. I guess everything that is a data set, very often we have a client doing the storage and then very different parties wanting to retrieve the data set. And and the clients may not want everyone on the internet to be able to get the data, only the authorized parties. And now in a decentralized system, there's really no good way to implement ACL other than like maybe cryptographic ACLs. And there are some good constructions, but now again, there are clients who are not satisfied with good cryptographic constructions. They need those bytes to actually never leave storage unless they are leaving it to an authorized party. So yeah, this is again where TEs can shine, and in general, like the storage can the client can authorize the retriever to be able to go to the provider who hosts the secure enclave, which is able to verify that okay, this person has the right to retrieve the data, and then pull the data from the secure storage and send it to the retriever. And then the other thing that happens in those storage networks is there are proofs about the data stored being computed. Those are generally ZK snarks, which is zero knowledge, I think, arguments of knowledge or something like that. And those are kind of ways to compute numerical proofs into very tiny proofs, which actually do not leak any knowledge about what was input into the proof. So now it's even possible to compute proofs that the data is stored correctly without exposing any of the data to the provider. And this is maybe like a bit into the weeds, but also really important for some clients. And data deletion, already touched on that, but generally it could be a really powerful primitive. And yeah, then the attestation in decentralized networks. So really, it's just a proving system, kind of like ZK snarks. And so the way those proving systems works is there is kind of one function which makes it possible to create a proof. And this generally has the kind of two inputs. So public information and private information, and then a verify, which takes the attestation or proof and the public information and returns whether that's valid or not. And so one example of what is kind of this proof is, let's say attestation says that private data is some raw data, let's say 1 gigabyte file, and public data is just a hash of the data, like let's say SHA-2 of the data. And the test would say, okay, this data hashes to this hash. This is the attestation that says this is the case. And you couldn't possibly create an attestation that say this data maps to this wrong hash because the attest function would fail. And then the verify function just takes the, in this example, would take the hash of the data and the attestation, and then would say true or false. And now if it is true, it means that the person who created this attestation had the raw 1 gigabyte file. And the attestation couldn't be created without it. And now it's possible to put really anything in the public-private fields, and you can prove basically any arbitrary thing about the data. And this is what ZK snarks allow you to do, but they are thousands of times slower than running a native CPU. And so might seem like a big deal for most things, but there are some things that need to be proven that, there's a difference between hosting one server and 1,000. It's a pretty big difference. So yeah, the main challenge in the space is really no one understands the security of secure enclaves, and most people are quite pessimistic about it. So like talking to most engineers in the space is you can start a conversation, and the first response is, oh no, I don't want to touch this because it's been broken over and over. And generally there's a whole bunch of time sunk into explaining it to everyone that's like, oh, well, it's not as bad. And generally people do acknowledge that there is quite a bit of value. But yeah, so there's like a big confidence problem. And so like one thing to mitigate that is to have more like clear assumptions. So it's like the assumption of like there is a finite amount where things can and will be broken. And there's also the kind of thing where there are actors here that have to be ultimately trusted, but kind of those same actors have to be ultimately trusted for just anything else. Like, there aren't that many companies building CPUs, let's say, and everyone uses them, so they better be trusted. So yeah, there are mitigations. So just don't put too much trust in a single VM. So like don't have like $1 billion secret in a VM that can be run by anyone on the internet. So just terrible idea. Then yeah, just avoid sharing secrets, and or like just avoid putting global very important secrets. Just don't make a thing that everyone can run. You're like $1 billion target, because someone will eventually be motivated to break it, and they might, or they might not, and that is not clear to developers. So yeah, there's also kind of the option of open sourcing parts of like the very critical parts that in theory shouldn't be breakable. So maybe open sourcing some critical parts of the firmware or even hardware. It doesn't even have to be everything, just kind of the things that establish the root of trust. But yeah, so yeah, going into the use cases of attestations, kind of having the why isn't there much more enthusiasm about the way? Yeah, how are those attestations useful? So first, for really large computations, there are some limited ways in new research that allow proving larger computations more efficiently, but it's broadly still not even close to native CPU speed, and more than likely will not ever be. maybe for some really specific proof types, but in general, being able to run compute at almost native speed and then create attestations, which are essentially just a proof in this context, is really powerful. And so, yeah, like one example we have is proof of data integrity, where storage providers can be asked by their clients to create an attestation which proves that they have access to every single last bit of their data and it's not corrupted. And this can be done just, kind of like it's like known as data scrubbing in like most file system areas. And this is a thing that is kind of important for more enterprise users, where they're not happy that they have 99.9999 something 9% of the data. They also care about the longer tail of nines, or like they actually want 100% of their bits to be there, and they want the proof of that every week. It's utterly not possible to do without these while having these storage be efficient. There are workarounds, but tangential. And like obviously it's possible to implement something as a hybrid of proof and compute. So it's possible to do queries over data sets in a way that the query results are proven. Like you could literally just run SQLite instead of the VM in a conventional compute VM, and that would already be just a magical self-proving results thing. Similar with retrieval. Retrieval is one of those things that is not really possible to prove, but it is possible if the two sides that are exchanging the data are running the code that is possible to that can create attestations on both sides. And yeah, like you can actually prove data exchange this way, which is also a thing that's not possible to prove, and it's been formally proven to be impossible to prove without assuming a secure execution environment. Kind of similar to retrieval, just proving this access parameters. So just being able to pay for access speed, bandwidth, and so on. And there are some later use cases. There is actually one company, at least I'm aware of, that is actually already built a thing around this, but it's kind of limited, but not having access to start. So, and I believe they already use SNP or TDX or both. So yeah, but this again is really limited by not having certainty on the security bound, and yeah, it's kind of unfortunate. Like the security bound is the word used in the decentralized world to describe of how much value is this primitive able to secure without being broken, or like how much money would a motivated attacker need to spend to break this primitive. And this is not a number that is really known in, when evaluating these. So yeah, the things that are needed is some kind of runtime, and this may or may not exist already. I've really only done like 3 weeks of deeper research into TEs. Maybe the fact that it took me 3 weeks and I still don't know is also a good feedback to create maybe like some more ecosystem overview documentation where it'll be much easier to find this. But yeah, the short version is the runtime that's needed here is something where it is really easy to ship code that creates those proofs attestations in really light virtual machines that are very, very locked down. So like super secure. I see a hand mic.
Yeah, so that is exactly what we designed NARCs to do. If you look for NARCs.io, it's one of the CCC projects. It's currently quiescent. No one's working on it, but it uses WebAssembly to provide you with a very, very
NARCs,
light.
yeah. That is in the next slide.
Oh, that's very nice to hear. So I'm the co-founder, and Nathaniel, if he's back, is the other co-founder of that. So okay, cool. I'll shut up and let you carry on.
Yeah, but that's kind of, there needs to be this runtime. Now, what it needs to do is just run really simple components. It's a general proof primitives are very, very simple, and it's kind of rare to see proving schemes where whatever is proven is extremely complicated. Persistent storage isn't even necessary, and yeah, the one thing that's needed oftentimes is really high throughput, kind of having access to HPC primitives and churning data for data really fast, because often it will be kind of database queries or just going through large data sets. And in general, that means like 100 gigabit, 400 gigabit kind of data rates. And like at those speeds, it kind of would be really nice to have even maybe easy access to RDMA like primitives to get access to data. But even without that, you know, like it probably cannot be WebAssembly as much as I could. But so yeah, this really looks like function runtime maybe, and the like rough architecture here is there's some function that runs on the provider that has access to data on the provider that can ingest a lot of it and just spew out a very tiny attestation at the end. So yeah, it exists. As far as I am aware, it's only wasn't time, and wasn't time already actually worked on a couple projects involving it, and really nice. It's extremely fast, but I don't think it can go that fast. Like kind of the difference between writing code in Rust and hoping it go fast versus writing AVX512 assembly, having it go really, really fast. And
yeah, so we designed NARCs to allow you to swap out that layer if you wanted to, as we use wasn't time as the main, but partly because it allowed us to make the highest assurances in terms of security. But it should be possible to have a different execution layer if you want to do that. So it is possible.
Okay, yeah, so that might be a really good candidate then. Yeah, obviously Cocoa maybe stacked with some functions as a service, like OpenFast or something in this theme. And possibly I'm also missing things, but yeah, like if nothing here can work, then it shouldn't be too wild to create something more custom, because it really should be like a really locked down OVMF and like Linux, maybe not even, because the computation is kind of really just reading data from some source and then outputting the result. Like it doesn't even need, I mean, it would be nice if it could run in VM user space, but maybe not necessary. But yeah, so some runtime. Then there's kind of this blockchain related part often appears. So essentially just PKY on chain and like kind of just code to verify attestations, but kind of in the blockchain world. So kind of rewriting what kind of already exists outside of it into that kind of weird realm of having weird limitations on how things are done, but shouldn't be too hard. It just no one asterisk. One group exists that kind of did it, but yeah, there's some work to be done on that front, and then yeah, so there's like this group, Marlene, with their Oyster project that seem to have done most of the work already. And yeah, I'm not really aware of many others. There are some projects that seem vaguely interested in at least SMP and TDX in ways that would also require this work. So there's probably already happening somewhere in the shadows. So yeah, the challenges, what's also needed. So I was kind of surprised to learn that confidential compute work even exists a couple of months ago, because I'm kind of working with like the bleeding edge of server hardware, and like I heard the term bounce around but never looked into it. And when I discovered it, it was kind of mind blowing. It was like, oh, this exists for years and I've never known. If I don't know, then most people don't know.
Yeah, our job is to try and change that, and we'd love to have more suggestions about how to do that. So please work with us on that.
Yeah.
I see 2 hands from Stefan and from Dan. Dan was first, I think.
Great talk so far. Just a heads up for people who are coming down in the last few minutes. We've got questions. Make sure you get them in for Magic here.
Okay, yeah.
As far
This
as
is usually the
verifying-
left side.
Okay, great. As far as verifying attestations on blockchain, I'm dropping a link in the chat of we had a consensus mechanism in a project I did several years ago that relied on an enclave, and in order to make sure that that was verifiable across the chain and sort of in the, for people who haven't worked on those, there you need to be able to always kind of like replay transactions from the start of time and forward, and keys will expire and be rotated and stuff. So some of the things that we did to make that functional in those constraints was to like kind of commit some of those artifacts onto the chain, so that at any point in time you could verify an attestation on there.
Yeah.
That is really useful. Also, Stefan.
Yeah. Hey, first of all, thanks for letting Magic present. Magic, great job. As maybe most of you know, or maybe not, we are part of the Decentralized Storage Alliance, right? Started by Falcon and Protocol Labs. Our goal is exactly to what you were just describing. Magic is like, hey, I didn't know about confidential computing until like a couple of months either, but we can help put it on the market. We can help promote it. Also, we're seeing like more in the last couple of months, more focus from some of the decentralized computing networks, focusing now on TE specifically to go after smart agents and this whole AI wave. So I think we can collaborate there by demonstrating how a decentralized storage layer plus decentralized compute that supports TE, and how enterprises can take advantage now of these new technologies in a secure way.
Please get in touch with me and let's discuss how to do that. This is Mike Bursell. Okay, exactly. Very interesting. Thank you.
Yeah, so kind of wrapping up, also hackers would be really welcome. This ecosystem is super open. And yeah, if there is anyone, any questions, maybe now, maybe not now, if there's other things to be addressed, but yeah, and this is my email. So if there are any questions, feel free to mail that. Maybe there.
Okay, well, thank you so much for the talk. We're down to our last minute or two here.
Thank you.
Just dropped into chat as well. The CCC has a project called Verizon that is an open source verifier. Also out in we have sort of a sister project in the CNCF called Confidential Containers. And that also has an open source verifier called Trustee. And that can either reflect things out to a vendor's verifier, or I think maybe be able to do it locally, which I think you would need for on-chain verification. So a couple things out there that might be of use to you.
Amazing. Thank
Thanks, folks. Another really interesting set of things going on, and we got a vote on a new project as well. So really good. Thanks, Dan, for running it.
Yeah, absolutely. So if we just kind of look forward to 2 weeks out, a couple things that we had sketched out were scrubbing our project liaisons list. So we wanted each of the TAC members to be able to keep tabs with one of our projects. That's a little bit stale in places, so we're going to do that. And we've got another tech talk coming up, and we've introduced this workload identity concept, so that would kind of cover the third topic area. But if other topics occur to you, we can always get things shuffled in and keep conversations going on the mail list. So please make use of the TAC mailing list. And with that, I think we can wind things to a close. So thanks to our newly joining colleagues here, Evharisto, Spiros, Johan Vayadanke, and to our recent presenter, I think probably Jenki is in order.
Thanks, everyone. Have a good rest of your week. See you soon.
you.
Thank you.
Thanks, everyone. Great job, Dan.
Thanks, everyone. Bye.
Everyone, thanks, Alex.